Welcome to a new video, guys. This one's about an exponential function, so let's have a look. Natasha carries out an experiment on the growth of mold. She believes that the growth can be modeled by an exponential function given over here, where P is the area covered by mold in millimeters squared, T is the time in days since the start of the experiment, and A and K are constants. The area covered by mold is 112 millimeters squared at the start of the experiment and 360 millimeters squared after 5 days. Question A, write down the value of A. Okay, so, well, the value of A will be the following. The value of A we can identify by doing some substitution. So, for instance, the beginning of the experiment, the area, which is P, is 112. So when time equals to 0, I put 0 into t. P of 0 equals to a times e to the power k times 0, which is equal to 112. So P of 0 equals to a times e to the power 0 is just 1. A times 1 is 112, which means a equals to 112. We just figured one constant, so that's nice. Question B. Find the value of k. Well, for the value of k we have the following. We can do some substitutions. We can do the following. We know that after 5 days the value of p is 360. So we would have a times e to the power 5 times k equals to 360. Okay? Now a is 112 times e to the power 5k equals to 360. You can figure this in a nice way on a graph. I advise graphs for exponential functions. So let's say you keep k on the horizontal axis because it's the input, and let's say you have over here the area, which is p, right? Well, you go to your GDC, to the calculator, on the graph, and on the graph they ask you to put the function. But the GDC says f1x, so you have to write it as a regular f of x function. Well, you just write this thingy, and instead of k, you write x. So that's 112 times e to the power 5x. You do that, you're going to have an exponential function which looks like a rising curve. So it looks something like this. This is what you're gonna have. Okay, so it's gonna go like that, and it goes up there. Then you want to find the following. This function must give you an output value of 360. Also on the graph you can choose the second function by pressing tab, and you're gonna have f2x. f2x must equal to 360. So the calculator is going to intersect the graphs at the line of 360. And finally, you should know that there is the point of intersection. When you analyze the graph, you can choose intersection, and you're choosing this point of intersection, and the value that you have on the horizontal axis is your answer for k. And to be precise, the horizontal axis for this point of intersection is 0.234. In other words, the solution to this equation, you can conclude through the graph method that this is 0.234, and that concludes our exercise. Hope this was useful, guys. If you liked the video, please make sure to like the video. If you follow the AI standard level course, make sure to subscribe because it's gonna be full of content relevant to your exams. Hope this all made sense. I'll see you in the next one. Bye.